Hey guys, it's Leia. Today we'll learn how to solve integrals using integration by parts. Integration by parts is a method used to solve integrals with complicated integrands. It uses the concept of U substitution. So when you're given an integral in the form of f of x times g of x dx, you can actually set that equal to the integration by parts formula, which is uv minus the integral of v du. We get the variables u and v from setting u equal to f of x and dv equal to g of x dx. We want to take the derivative of u to get du, and we want to take the integral of dv to get v. Once you get all these values, you plug them back into the formula and then you get the answer. And this will make solving integrals a lot more simpler. Here are some tips for using integration by parts. First, you want to give integration by parts a go when U substitution doesn't work and the integrand looks complicated. Second, you want to pick dv to be the complicated function and pick u to be the function whose derivative is simpler than the function itself. When picking what u should equal, following the order of this list is very helpful. Now, this list doesn't always work, and sometimes you just have to use trial and error to figure out what u and dv should be equal to. Third, you may come across an integral that requires you to use integration by parts more than one time. In this case, make sure you write it out very neatly. Let's see our first example. We have the integral of x squared times ln of x dx. We want to find what u and dv are equal to first. We consider the list of what to set u equal to. We see that there is a logarithmic function in the integrand, so we set u equal to ln of x. That means dv is equal to x squared dx. Now we take the derivative of u, which is 1 over x, and we take the integral of dv, which is 1/3 x cubed. Next, we refer to the integration by parts equation. We'll substitute in the values. Next, we'll simplify the equation, and we can see that this is a lot easier to solve now. So we take the integral of 1/3 x squared dx, and we finally get our answer, which is 1/3 times x cubed times ln of x minus 1/9 times x cubed plus c. Next example, we have the integral of x minus 5 times e to the x dx. Now we have to figure out what to set u and dv equal to. We keep in mind the list of what to set u equal to. There is not a log function, an inverse trig function, but we do see that there is an algebraic function. So we set u equal to x minus 5, and that means dv is equal to e to the x dx. Now we calculate du and v. Next, we use the integration by parts equation and substitute in the values. We have a nicer and easier looking equation to solve now. And we solve the integral and get our answer, x minus 5 times e to the x minus e to the x plus c. Last example, we have the integral of ln of e to the 2x dx. We have to find what u and dv are equal to, so we refer to the list. And we see that there is a logarithmic function, so we set u equal to ln of e to the 2x. So what does dv equal? Don't forget there is still a 1 dx in the integrand, so dv simply equals 1 dx. Next we calculate du and v. We use the integration by parts equation and plug in the values. We then solve the simple integral of 2x dx, and we get our answer, x times ln of e to the 2x minus x squared plus c. Integration by parts is a very useful method when solving complicated looking integrals, so it's very important to understand this concept. For more help on this topic, visit www.symbolab.com and click on the Practice tab.